Hello friends, I'm Ulhas Joshi. Welcome to my Back to Basics learning series. In every session, I will take up one of the many terms, concepts or words that we use in our day-to-day conversation, and I will explain that in a simple way for our better understanding. In this session, we take up the term compounded annual growth rate or CAGR. We all know that growth is an important metric to measure performance of a brand, a company, an institution, a country, and so on. It's a measure of change from one period to another and is always expressed as a percentage. Let's see an example. We have in this table here the sales figures of a company for the period 2017-18 to 2021-22. If you wish to calculate the growth that has taken place in this company every year, you compare two periods at a time. For example, for 2018-19, the growth over 2017-18 is calculated in any of the two simple ways shown here. First, you could just subtract 2925 from 2352, you get 573, divided it by 2352, which is the base year, you get a figure of 0.2436, and you multiply that by 100 since growth is a percentage always. So 24.36, which is approximately 24%. Or you just use a formula. Into the brackets you mention 2925 minus 2352, divided that by 2352, you minus that by 1 and multiply that by 100 and you get to 24%. In the same way, calculate the growth for the other years. So the simple annual sales growth figures during 2017 to 2022 are 24%, 3%, minus 18%, and 27%. You might look at this figure of minus 18% and then recall that in 2021, the pandemic has caused probably a decline in the sales of this company during the previous year. You can understand quite a bit about what is happening in the company when you look at the annual sales figure. But suppose you want to consider the annual growth for the entire period between 2352, between 2017 and 2022, starting with the figure 2352 and ending in the year with the figure 3150. A simple annual growth may not give you a representative annual growth figure for the entire period. In some years you have grown, some years you have declined. So what could be a representative growth for the entire period? For a representative annual growth figure, you need to calculate the compounded annual growth rate or the CAGR. So what is compounded annual growth rate? CAGR over a time period is that constant percentage rate at which a parameter's value in the beginning year grows to the parameter's value in the final year. In our example, CAGR is the constant percentage rate at which sales of 2352 lakhs in 2017-18 grows to the sales value of 3150 in 2021-22. So there is a formula. If you have n data points, in our example we have 5 data points. If you have n data points, then you use this formula. CAGR equals last data point divided by the first data point, that bracket raised to the power of 1 divided by n minus 1. Minus 1 from this and multiply that by 100. Slightly complicated, isn't it? So let's see the example. The first data point in our example is for the year 2017-18. It's 2352. The last data point is the data for 2021-22 sales, which is 3150. The number of data points in our example n is 5. So what do? We divide the last data point by the first data point. 3150 divided by 2352, which gives us, as you see in this slide, 1.339286. Now you raise the number to the power of 1 divided by n minus 1. See the formula given below. Raising a number to the power of 1 divided by n minus 1 is the same as the n minus 1th root of a number. So if you have n equal to 3, 1 divided by n minus 1 is 1 divided by 2. So when you raise the number to the power of 1 upon 2, it is taking the square root of the number. Likewise, when n is 3, 4, 5, 6, whatever. So in our example, we are raising the number 1.339286 to the power of 1 upon 4. Raising a number to the power of 1 upon 4 in our example gives us a figure of 1.075767. You can try it out on your computer. Minus 1 from that, the answer you get is 0.075767, as shown in the row H in our example above. Multiply the answer by 100 and you get 7.5767. You could show the answer in 2 decimal places, so you get CAGR equals 7.58%. This is the normal way in which CAGR can be calculated. If this formula seems complex, and if you have been using Excel for your work, then let's use an Excel sheet and calculate the CAGR. Place the figures on a worksheet. In column B, you have 2017-18 with the sales shown in the cell B2 as 2352, and likewise for the other 5 years. In our example, the last year is 3150, first year is 2352, number of data points is 5. So if you see the column C and the row 9, there is a formula which says equals into bracket F2 divided by B2 raised to the power of 1 divided by D7 minus 1 in the whole bracket minus 1. This is a formula which, if you apply to the data that you enter in your worksheet, where F2 is 3150, B2 is 2352, N equals 5, N here is D7. D7 minus 1 is 4, and you put in this formula and the Excel sheet shows you a figure of 0.07577. Multiply that by 100 and you get 7.58. If you save this formula and apply it to your work whenever you calculate CAGR, even if you have data of 7 years, 8 years, 9 years, N changes and the data that is shown in the last column is compared with the data in the first column, and you get the figure of CAGR. So you have learned 2 methods, a formula method and an Excel method. Both seem a little complex, and if you want to learn a shortcut method, I have one for you, that as well. An easy shortcut method using only your calculator. Now this you can use if you have 5 data points. It's a little more complicated when you have 7 data points or 6 data points or 3 data points. But when you have 5 data points, it's very easy to calculate CAGR using your calculator, provided your calculator has a square root facility. So try out yourself using your calculator. You have the same data, 2352 growing to 3150 in the 5-year period that we have. So take the last data point, type 3150 on a calculator, divide by 2352, and you get a figure 1.339287 whatever. Now take the double square root of the figure that you have got. A double square root is the fourth root. A square root of a square root gives you the fourth root. So I say take the double square root of 1.33928, the figure that you had got in the previous slide. The square root of 1.339 entire number equals 1.15. That's the square root taken once. And the square root of the square of 1.15727512 equals 1.07576, right? So this is a very simple method. You just take the last period, divide it by the first period, take the double square root of that, then minus 1, you get 0.075767, multiply that by 100 and you get 7.5767. And 7.5767 rounded to the nearest decimal place is 7.58%. So this is very easy to calculate when you have 5 data points. If you have just 3 data points, you take the square root only once. Just to explain why it is a double square root, you are taking the fourth root, a square root of a square root. And 1 upon 4 raised to the power of 1 upon 4 is what you have got in your formula in the previous slides that we had seen. 1 upon 5 minus 1 is 1 upon 4, which is the fourth root, which is the double square root. So this way, I find it very easy to calculate the square root very quickly just using my calculator. You have your calculator in your mobile, you have a separate calculator, you can use your laptop, you can do whatever. But it's a very simple calculation if you do not want to go the formula way. So try and do some examples yourself using any of these methods, and you can be confident of your CAGR calculations. So this is what I have tried to explain today, and that is the concept CAGR, compounded annual growth rate, demystified for you. Thank you very much. If you like this session, subscribe to the channel and like and share with your friends and connections. Thank you.